guys. Really appreciate you being here as well. So, Jake, let me start with you. What do you think on average, what percentage of late model vehicles, so 2013, 14, 15 area, what percentage of those vehicles do you believe need some type of collision repair diagnostics when they're coming to your shops?
Well, based on my personal experience, I think that figure's close to 75%. And when you figure the obvious stuff that's whether it's an airbag deployment or traction control issue or something like that, you take the obvious stuff out of the picture and you look at the OEM requirements around 0-point calibration, like Toyota's crib number 177 that states that all their cars have to be scanned in the event of an accident. I think that number filters around 75%.
Yeah, I'd agree with that. It's much higher than it used to be, especially as we've seen a number of different electronics control modules kind of leak into every corner of the vehicle. That we find that even in a very simple procedure such as replacing a bumper, in years past they didn't have a park aid, and now we're seeing park distance sensors in those bumpers, and oftentimes they have to be initialized or reset when simply doing a bumper replace. So that's kind of led to that increase in percentage of need for diagnostics.
And what are some, you mentioned the park assist systems and traction control systems, and restraint systems aside, what are some of the most common collision repair issues from a diagnostic standpoint that you're familiar with, that you run into?
I think we focus a lot on safety, which is very important, but I think we neglect comfort and convenience. If a customer's ambient temp sensor is unplugged and then all of a sudden their auto air conditioning doesn't work, that's a CSI problem. They're going to be back in our lap understanding why is my car worked this way before an accident and now it doesn't work that way anymore. So I think that comfort and convenience is something that definitely gets ignored. We do a PDR on a roof and we forget to plug in a Bluetooth antenna. Once again, I can't make my phone call in a non-hands-free area, and I'm making that U-turn right back to one of our stores. So I think as we encounter these systems, we really have to be cognizant of that.
Same thing does the driver assist system?
Yeah, absolutely. It's the unseen, It's very easy to identify when you have a trouble code, when you have a light staring at you right in the face, but it's all the other systems that we get into. If it's detrimming a door and a door integration module, auto up features, many things that he said as far as the comfort and convenience systems on that vehicle. And it's interesting when you find that many of those vehicles make their way to the dealership at some point, and when they plug into it and they pull the list of 62 body codes that had never set a light, however they're stored in the vehicle, and they come to the customer and say, was your car taken apart? Has it been in an accident? And in fact it was, So being able to kind of identify what else is going on outside of the lights, I think is going to be really crucial for CSI mainly.
Yeah, and that's a great point. I think one of the misconceptions out there is that, well, if there's no light on, it's not a problem, right? So it shouldn't be an issue. I think there's be more and more systems that are going to not turn a light on, but are going to set those 62 codes in there, and more probably as well moving forward. So that certainly is an issue that we need to deal with, because again, they're not going to turn lights on, just that the system isn't going to work. And I think about somebody maybe in downtown Detroit or downtown Chicago or a big city where they've got maybe an adaptive cruise control system or a lane keep assist system, and maybe they're not going to get on the interstate for a week, a month, 2 months, who knows. And now that vehicle is no longer operating properly, and it's like they're trying to figure out and go back to the dealership and trying to hunt that down. So I think it's important and to make sure that we're doing that. So, what are some of the other issues that could arise if we're not doing some of these diagnostic procedures when the vehicle's been repaired? What are some other issues that we might arise again? Something that's not turning a light on, aside from the Bluetooth and some of the other systems. What are some other things that could potentially happen with that from a safety standpoint?
Well, I think that we, as an industry, we focus on the light too much. Where in a collision event, that car's had key cycles and miles driven occur because the consumer's doing those things. But in a collision environment, we're not driving the cars and we're not cycling the keys. So the car hasn't had a chance to turn a light on in some cases. So, if we leave a steering angle sensor neglected, it could result, and we don't calibrate it as part of our repair process, it could result into a drivability issue and up to a crash, after the customer takes possession of the vehicle. So I think that's a huge deal. And the fact is, how do you know unless you've checked?
Dennis, what kind of approach does Snap-on take when it comes to diagnostics? And how do you determine, which programs you're going to be building into your system?
We pretty much have a group of people that go through and plan the pieces that we're going to do for each development cycle. And that group of people, that comes from the automotive side. We have some people that give us some body input on stuff that's wanted there. And then we have our developers themselves. And we have wants and needs that people have called in. So we have a list of all of those. And those all get put through a process. And we go on and develop those.
What are some of the differences between the tools that you offer and say an OEM specific tool? So you and the other ETI members and aftermarket scan tool companies, what are some of the differences between the types of equipment?
The big difference is the factory scan tool has to cover everything on the car. They don't have a choice. They have to cover everything. But they cover one car line, one make. Right? So the big difference is we cover several. Do we cover everything? No. We obviously cannot. To do that, I'd need a staff of several hundred, maybe thousands. I cover over 200 different makes in the world today. So
It's a lot of cars.
it's a lot of cars.
And are most of these systems, SAEJ compliant? I always forget the number that you guys are always referencing. Are most of these advanced safety systems, are they compliant with the OEM2 pieces as well or not?
Most of it. They don't always give us everything, and then the pieces that we're missing, we usually try and reverse engineer to get them in. So like with an aftermarket scan tool, there's no one tool that'll solve all your needs. You're going to need multiples. I mean, I tend to think ours is better, but I'm a little biased there.
Now, Chuck, CDS has taken a quite different approach to diagnostics. Can you share a little bit about the approach that Collision Diagnostic Services has taken?
Yeah, it's in collision. It's quite unique. It's because the vehicles are still under warranty. They're not the kind of vehicles that are going to go into a regular repair shop. But once it's been into a collision, the collision shop is tasked with all the systems that are on the vehicle, making sure that they work properly, and that's to the point to where you really need the OEM coverage on the later vehicles and the different systems. And you kind of go back to the OBD2 specification. That's mainly for the powertrain stuff. There's some different J specifications that cover a few of the other systems, but when you look at the entire vehicle, there's many proprietary type protocols that only the OEM scan tool covers, and with the latest updates. So it's there's a lot that can be done with some aftermarket scan tools, but you don't know what you missed unless you can see everything. So that's the approach that we had taken. The other portion is, in order to be equipped, collision shops can't really choose to be, I just work on Hondas and I got Honda equipment. I just, on one car line, they got several car lines coming in, and the amount of expense to be able to have all that equipment for all the different OEMs, and also be trained in all those different systems and familiar with them, it's the cost barrier is huge. So our approach is with the connectivity with a single tool, and then using a specialized diagnostic technician with that OEM experience, and also understand how that OEM scan tool works and the software works, and provide that to the shop with diagnostic assistance on a per vehicle basis.
So can you tell us a little bit more about how the process works? So I've got the Aztec in my shop, and I've got a collision damage vehicle that comes in. When do you first recommend hooking that system up and contacting you? Kind of walk us through that process?
Yeah, absolutely. At the very beginning of the repair, before anything is taken off that vehicle, anything that's done, because you can induce codes just by starting to disassemble the car. So now that kind of pollutes the data that you're collecting, determining what's wrong with that car if you start too late in the process. It's that pre-repair stage so that you can identify stuff. And basically it's what the shop does. They go online, they put in a service request, we see it immediately, we respond to them, they connect, put the vehicle in the same state as you would for a scan tool to be able to scan it, and then that's when we log in and we look at the entire system on the vehicle. And any information the shop can give us, where the vehicle's damaged, and we can alert them that this vehicle has issues with park assist, it has issues with object detection, And if freeze frame and snapshot data is available in certain areas of the vehicle, we can also tell if if a certain situation was pre-existing or if it happened near the time of the accident. That data isn't there every time, but when it is, it's very valuable. And then of course, then we can help them also determine, like, airbag module replacement is now conditional for the module itself when there's a deployment. So if we know that there's a deployment, we can usually tell by the codes, but we can go in and look at that module and determine from the status of the code if module replacement is a necessity or not. So a lot of modules get replaced arbitrarily just because they're not checked for that state. And then at the end of the repair, when everything's fixed, everything's put together, go in, clear the codes, do the calibrations, program the modules that have been replaced, do a complete setup. Now you've got a clear slate on the vehicle for a QC test to make sure the vehicle's roadworthy before delivery. And same process with the scan. Putting in a service request, we connect and then walk the technician through.
And how many models are you currently, or how many makes are you currently covering with that?
At this point, we cover 26 manufacturers or nameplates in the North America market. And for all the main ones, there's about 36 to 39 in the American market of the mainline vehicles. We're continually working on research and development to add that full coverage.
Now, Ben, I think one thing that a lot of people have the misconception again about is you hook the scan tool up, you push a button, and you're kind of done, right? From a collision standpoint, anyways, what other tools do you need when you're going through that process? Different types of information. What service do you offer?
Yeah, well, it's a great question. I think Dennis actually touched on it and said that scan tool is just another tool, right? I mean, it's one of many tools in your toolbox. So a common thread of what we're talking about here is information, right? It's information that you get from a tool, from a service, and in our world, from the OEM and from the industry about what you do with the information that you get off the vehicle. Because once you've got the information off the vehicle, it may point you to a code and says, hey, the code says that there was a improper voltage on the IAT sensor. But what do you do about that? You don't replace the sensor just because of that. So then what we provide is the reference information that says, well, a couple things we can offer is, like, from the OE's perspective, when you get this code, here are the steps you take, the measurements you need. So other than a scan tool, you're probably going to need a DVOM, digital voltmeter. And in the more recent cars, I'm hearing a lot actually at this conference about the fact that oscilloscopes are likely to be coming back, because sometimes you just need to actually be able to look at how clean a signal is on a line and things like that. But the information from the OEM can help the technician follow the steps necessary to understand what the root cause was that set that code. And then what we are also doing a lot with now is industry information that says, if you've got a 2007 specific year, make, model, and you've got a specific symptom, we can actually tell you, we've seen that symptom a lot of times, and here are the top 5 things that cause that symptom, and here's the probability that those things occur in, and things like that. And as I was thinking about this panel a lot, and thinking about the collision industry and the fact that some of us that were techs, we kind of grew up from almost no electronics to where we are today, but we were part of that evolution. And it strikes me that a lot of the collision guys grew up in a different evolution of different materials and ways that you had to deal with putting a car back together, but now they're kind of getting slammed with a crash course of having to understand all the things we kind of just grew up with. And so I think in your world, in the collision world, it is going to be important, and frankly, the best tool you need is your head. You need the best repair happens when you understand how a system works. Now, considering we can't take all the techs and give them from A to Z how all the systems work, industry experience is like having a whole bunch of your best buddies and says, have you ever seen this before, and what did you find? And that can help, and then that points us into a situation where we can say we can either take the OE information now that we've identified the root cause, here's how I replace it, here's how I calibrate it, here's how I do whatever with it, and move on. So the services we offer, I think, are very complementary to using the information that you get from other sources in a practical way to try to get the car repaired properly and fast. And we were talking about codes earlier. It was interesting, again, thought a lot about this collision world. In the mechanical world, a code will set because a set of conditions happens, and usually the car comes in because of the light. When the collision event, the car got hit, you've repaired the vehicle, you've got it where it aesthetically looks right, and it starts up and there's no lights on. But for a lot of these codes to actually set and for the light to come on, a specific drive cycle has to be run before that can happen, and you won't know for some period of time whether or not the conditions are now there that when that drive cycle happens, it's going to light the light. And depending on the severity of that code, you may have to have multiple drive cycles. It'll set what they call a pending code, and so it could be a while, which introduces the doubt even on the collision shop side, saying, hey, I fixed that car 2 weeks ago, man. It's not my fault, but it could have very well been a result of the accident. And so those sorts of reasons, I think Jake said it, you never know unless you ask, and the way you ask is to plug in and get the info off that data bus. And unfortunately, even then, you may have to drive the vehicle, to really be sure.
You mentioned oscilloscopes and DVOMs and bus systems. Those are words that are, don't always hit home with us on the collision side. So what type of background knowledge do you need before you start getting into the diagnostic side of it?
Well, like I said, the best diagnostic event happens if you understand the system you're working on, and realizing that that's not always practical. I would recommend, back when we started evolving from on the mechanical side, I used to actually teach a course for General Motors. It was called just basic it was called specialized electronics training, and then I taught for some other companies. But there's a variety, I'm sure, of course, is still out there. Just talks about Ohm's law and how circuits work and how electricity flows and how to measure things with a meter and what it means if something's higher or low. I think that's going to become a prerequisite. And then again, in the absence of being able to really go out and understand how an ABS system works, how a supplemental inflate system works, and then how it works in a Ford versus a Chevy versus a Toyota, I think that your friend is going to be as much industry information as you can get from others that might have experienced that problem. I think that this is a world of collaboration now where the collision industry can really look to the mechanical industry that's kind of seen and done some of these things. Now, we've done it for different reasons. We've done it because parts have just naturally failed instead of being, hit. But still, I think that it could give a collision guy a nice head start to be able to look into a database and say, hey, I've got this code or I've got this condition. Has anybody ever seen this before? How many times has it been seen? At least it may not identify the problem, but it's going to put me on the path, right? And it could probably shortcut a lot of the time that you'd otherwise just have to learn to really understand how the thing works.
Dennis, do you have anything to add to that as far as the training and the background information goes? There was something that kind of came up at ETI at our Isaac meeting there. Can you share a little bit your perspective on that?
I think the basic information is going to be electrical. Once a guy learns how to read an electrical system, then he can pretty much look at the diagram for the car you're working on and figure out how the system works. Because a lot of the collision stuff you're going to find is not necessarily broken parts, but stuff that's unplugged or some cut wires or something like that. And you got to find the circuit, and you got to be able to diagnose the circuit itself. So I think electrical is going to be a big thing for the collision industry.
Yeah, I think understanding wiring diagrams and how the systems function are certainly good. I think the one thing that we do have, we do have the collision advantage that the vehicle's been hitting the left front to the right front, so we know, kind of where that is, kind of a starting place versus if it's a failure type system. But obviously that's not going to address everything. And then certainly, Jake, the calibration piece is a big point, is a big one as well on that. So Dustin, can you go a little bit more into detail kind of about how you got into the diagnostic groups? I know that, and Dustin's been he's been one of our guys we worked with for quite a long time, and really kind of started me opening my eyes to this is an issue. It's a collision diagnostic technician, I think, is a role that's going to be essential in the not too distant future. So give us a little bit more background, maybe kind of how you got into that.
Yeah, so really I started out as an apprentice at a Buick dealer, and I was changing oil and just doing brakes, kind of getting used to the daily grind on the line. And we had a body shop dealership next door, and they started doing sending the sublet work over, and I kind of began to run into these issues now and then. And at that time there wasn't nearly the amount of electronics that we see currently. but it really began with steering and suspension, and then getting into ABS, and then as your different types of traction control and vehicle dynamic control started to show up, I was kind of faced with how do we get these functioning the way they did before the loss. And throughout that, I ended up actually moving to that body shop and then began the in-house mechanic. And that's kind of where the path down that collision diagnostics began. And so over about the next 10 years, it was all day, every day, in-house mechanic at a shop, that we produce several hundred cars a month out of. So there was no shortage of, there are lights on, this doesn't work, help me out. It's always Friday at 5 o'clock when that stuff ends up getting dropped in your lap. So, kind of to his point, in the collision world, the interesting thing is you see oftentimes it's a crushed wire or something is unplugged. And with the rise of the CAN network or controller area network, it just seems to really amplify that. You can have one module in a door trim panel that's perhaps one portion of that is unplugged or one pin is broken in a side impact where the harness got crushed. And now you have a multitude of systems that won't come online, and the technician's looking at it like, I didn't even touch the right side of the vehicle. I didn't even get into the sunroof. Why doesn't this stuff work? And it's a result of that one module in line not being able to communicate. So those were a lot of the challenges that we were faced with, and kind of going down that path of where this is heading. And you walk the floor here, and it's just there's electronics in every corner of the vehicle that we'll touch. And so I think it's going to only increase in importance, as we see autonomous vehicles and crash mitigation systems, not only for the functionality of the vehicle, but the overall safety for the consumer when they get that vehicle back.
So if you're seeing, 75% of the vehicles today that you're dealing with, you think you need some diagnostic, repair diagnostic work on it. Do you see this as a career option for some young adults that are coming through our current technical schools and colleges? And is it something that our collision repair schools should be starting to gear up for?
Yeah, absolutely. I think I had a very unique background, starting in the mechanics side while going to school for collision, and it gave me a very interesting skill set, and it was good timing in a lot of ways because of just how fast things were changing. And it became very common that you would have that vehicle come in and I don't want to touch this, I can't figure this out. And I was the young guy, so I got all those vehicles. And you started to look at, like I was saying, kind of how the industry is heading. I think it's a huge career opportunity for a lot of people that can have that, I don't want to say dual role, but background where they understand the diagnostic side, they understand the electrical side, they understand Ohm's law, how electricity works, and believe it or not, are pretty good with computers because there's a lot of technology in a vehicle that's scarily similar to a network in an office as to what it was, just switches and light bulbs, 30 years ago.
Same question to you, Jake. Do you see it as a career opportunity for young adults?
Absolutely. I think it's a tremendous opportunity for young adults getting in. Electronics, they're not going anywhere. They're going to be here, and I often relate the electronics in a car to the apps on a phone. And the deal is, we may not know how an Android phone works because I have an iPhone, but my customer knows how an Android phone works, and I better understand how those apps in that car work. And I think that individuals that are studious in their approach in regards to information, whether it be diagnostic or OEM information, to build a repair plan around a vehicle system, and their process in general are going to be a success.
Chuck, do you maybe share a story or two briefly about some of the things that you've run into with some of the with some collision-related information that perhaps just completely threw you for a loop?
Yeah, it's I'll keep it to a couple. So this we've got quite a few of them. It's but a couple that stick out as some of my favorites is we had a vehicle come in. Shop gets all done with it. They didn't pre-scan the vehicle. Did a repair plan based on everything they seen. They get done with the vehicle and they got a check engine light on. So there's a lot of things that could happen. We get into the vehicle. We're checking it out. We scan it, and we've got a code in the fuel pump control module for active grill shutter inactive. So of course we go into the active grill shutter, we start checking things out, we're not getting any response, we're not seeing any data. We call the shop, it's like, hey, did you plug in the active grill shutter? I said, what active grill shutter? Well, you know, the flaps underneath the bumper, there's an active, no, this car doesn't have it, we looked. I'm like, well, did you put a new bumper on it? Yes, we put a new bumper on it. And I'm like, well, where's the old bumper? Go look at the old bumper. The car came in with no bumper. So it was, of course, knocked off in the accident. So we get in, it's like, you need an active grill shutter. Now they got to completely disassemble the car, put it back together, add the active grill shutters. Then we got to go back in and do a minimum, maximum relearn on them so that the next time they activate, they don't set a code. So that was one that kind of stuck out, and the shop kind of, that really sunk home with them to look into the vehicle before they start doing the repair. And this all goes into a good repair plan and the pre-scanning. Some of the others, we've had multiple issues of these, but the thing that happens a lot when I talk about on the pre-scan and checking the vehicle out after an airbag deployment, there's lots of devices that aren't obvious when they have blown, and we see this consistently on post-repair scans. We get done, seatbelt pretensioners are missed. They say, well, it retracts just fine. It's still blown. It's showing up as obvious. But the big is the arbitrary replacement of the airbag control modules. So I have a lot of these airbag control modules that don't have to be replaced. You arbitrarily replace it. The old one gets pitched. We just ran into this not too long ago. Shop calls in, replace the airbag control module, and we need to code it. There's a very late model car. There's no backup coding available for that car. We need the old module. The old module's gone. They don't have it anymore. They just went ahead and replaced it and threw it away. So now this vehicle ends up stuck at the dealer waiting for 2 to 3 weeks for, it was a Volkswagen for Germany, to do all the research to come up with the base coding to code this because they didn't have the old module. Their other option was to buy another used module from an exact equipped vehicle, put it in, pull the coding out, and transfer the coding over. So that's another point that's very, very, very important, and that's, I can't imagine the pain that the shops go through when these happen, but just following the steps with a proper repair plan at the beginning, looking at the service information, as Ben alluded to, that's a very, very important piece of this. The scan tool's not going to do it by itself. There's a lot of times it appears the scan tool fixed the car, but it just completed a calibration or completed a routine. So it's, but those are a couple of my favorites. I could keep you here for a while, but I'll end right there.
And you know, Jake, I think you've told a story about an Audi Q7, I believe, that not only got the vehicle back to where it needed to be, but also protected the insurance company. And can you share us that?
Yeah, I like that one, but I had one recently here that happened in our new Philadelphia market. That, as we're training these stores, we're really emphasizing QC and all these things. And we were doing a simple repair on a bumper cover on a convertible Mercedes. And we, when the car got hit, as on a Mercedes, you could do that, and it deploys the headrest. So we had that reset on the, it's a mechanical reset on that car. And so, as part of our QC, we ran through and ran a diagnostic scan on the car. And Mercedes are equipped with a system called an air scarf. And it's got a vent at the back of the neck that blows across a heater element. It's a little motor. It blows across the heater element and puts a air scarf around your neck. So we get a diagnostic fault for inoperative air scarf on passenger side. And I said, guys, our customer sees seat repair, okay? That means you own everything on the seat, okay? So I said, I'm thinking maybe we popped a connector when the headrest deployed, or maybe we pinched a wire. You're going through all the obvious stuff. And so we pulled the seat back apart, and we found a gum wrapper in the seat motor, in the little fan that stopped the fan, checked the diagnostic fault. And I said, we just saved ourselves a revisit and CSI concern on that vehicle. And we made, clearly not related to the accident, but we made a happy customer as well. And, the one you talk about, the Q7, that was a vehicle that was hit in the back, and it damaged, it had a fault code for an inoperative nav system. And, the husband came in and said, of course, that's, my wife drives that car, but she said it was working before the accident. And the freeze frame data from the scan tool told us that they had put 9,000 miles since that fault was triggered, clearly way ahead of the data lost. And when we put that in front of the customer, he said, wow, she never mentioned this before, and I'm just learning this now. So, once again, save the insurer a lot of money, but we also put a path for our customer to get that fixed. As it turned out, Audi had a service bulletin out that corrected the situation where they put a new sunroof track in and it was leaking water on the nav unit. So everybody wins, and the car was repaired properly.
Dennis, is the collision repair industry something that Snap-on's taking a closer look at, as a potential growth opportunity for your equipment?
Yeah, we're taking another look at this industry again. In fact, in the last 6 months, I've probably visited 3 different body shops myself and sat there with the owners, and I wanted to go over how much money he was sending out of the shop because they didn't want to do any diagnostics. So they got the mobile repair guys that come by. You got the other shops. They send it to the guy around the corner or send it to a dealer. And a 4 or 5 person shop, this guy's sending $5 to $10 grand out a month. So you could pay for a diagnostic guy and bring that money in house, and he's just not doing it. And I see that at a lot of places. So we're taking another look at what are the other pieces that a body shop needs that we can add. That's part of the visits I've been doing is, what do you guys need? The main problem with that is most of the guys say what they need is the very last problem they had, which usually isn't what they really need. So it's hard to get the information.
What about you, Ben? Are you guys going to go a little bit closer look as well?
Yeah, I think it's fair to say, and we kind of say it, Snap-on's corporate philosophy kind of is that we're solution providers for the people that perform critical tasks, and that's across a lot of industries. And as Dennis alluded to, especially with the growth of complexity in today's vehicles, we're already in the collision business in some areas. We do frame straightening and frame measuring type things, but we are certainly, and I think Dennis said it, if we find areas that we think we can make a difference in a positive way in this market, I think you'll see more from us. So I don't want to take that as a solid yes or no. I'm purposely being a little ambiguous because I don't really know, but we're certainly looking at it very closely. And if we think there's a good opportunity that benefits the industry and benefits our shareholders, we're probably going to be doing something.
And I think it's an area certainly that iCar needs to continue to take a closer look at as well. Dennis and Dustin, as an iCar instructor, do you see this is something that we should be taking a closer look at and sort of develop some curriculum around it as well?
Yeah, no, absolutely. And I think really in recent years, you look at a lot of the newer iCar classes, and it's begun to really work its way into that course material. In fact, yesterday morning, I taught Damage 15 just upstairs, which is advanced steering and suspension. And it's all about electronics that have made their way into suspension systems now in the vehicle. So we talk about vehicle dynamic controls and adaptive steering and all these different types of electronics now integrated in with an item we would have just associated with strictly nuts and bolts and metal, not even 10 years ago now. So, I think we've done a good job of beginning that conversation, but there's definitely a gap there, and I think it's something we need to work on closing.
What do you think about that, Jake? You think that we definitely could use some work on there and close that gap a little bit?
Well, I couldn't agree more. And to Dustin's point, the nuts and bolts are changing around us too, and and the electronics is just one more piece of that. The idea is collision repairs. We make cakes. Okay, the OEM information, the diagnostic information, all of that's the ingredients. The cake ain't gonna taste too good if we don't have the ingredients right? So those are the things. When you look at that piece behind you with all the different colors, that is an example exactly what he was just talking about. And I think that, we have to change. We don't forget that we came from points, tubes, and carburetors, but we have to understand KERS and the MOST bus and all these things that are affecting these electronic systems on these cars.